Hello all, welcome back to my channel, and today we are going to study logical clock and Lamports algorithm. So in previous sessions we studied what is physical clock is. We studied that to synchronize the clock of client, it requests time to the server, and for that we have used different algorithms. For example, Christian's algorithm, Berkeley's algorithm, we use the NTP method. We studied what is UTC is and how UTC is implemented in different algorithms. If you compare physical clock and logical clock, you will understand that emphasis is given to the time in physical clock, whereas in logical clock, emphasis is given on the ordering, chronological ordering of the events. Leslie Lamport in 1978 first implemented the Lamports timestamp. Now using Lamports timestamp, logical clock is implemented. So what is the idea behind this Lamport timestamp? Whenever client will send any message to itself, that is from one event to another event, it will increment the counter by 1. Initially this counter value can be anything. Suppose we assign 1 value to the counter. Then what will happen if you are sending message from one event of the process to the another event of the same process, then the counter value will be incremented by 1. And if you send a message from one event to another event on the another process, then you need to check. And what you need to check? You need to use happen before relationship that I will show you. Now see this, A tends to B. This is what the happen before relationship. Now Lamport uses this happen before relationship. What is the meaning of this? Whenever you will send any message from one event to another event within the process or outside the process, you need to check whether A happens before B or not. That means what? B's value should be greater and A's value should be less. And then only we can say that A happened before B, because counter value you will check. If suppose A is equal to 1 and B is equal to 4, then that is correct, because A happens before B. 1 happens before 4. So they are the timestamps. 1 and 4 are the timestamps, or we can say counter value. So these values we need to check. If B is greater, then okay. If B is less, then you need to think about that. You need to recalculate and you need to resynchronize the counter value of the receiver. So Lamport algorithms uses happen before relationship to synchronize the logical clocks. So these are the formulas we use to increment the value whenever we will send message from client to server or one process to another process. So already I have told you, if you are sending a message from event of the same process to the event of the another event of the same process, then you will only increment value by 1. But if you send message from event of one process to event of another process, then you need to use this formula. And formula is very clear. CJB, that means what the receiver's timestamp or the counter, is equal to max of CJB, means what the receiver's value, current value, and you need to find out the max value from CIA, means what the sender or sender event, its timestamp plus 1. So suppose now the timestamp of the sender event is 60. So the value will become 61, and if receiver's value is 56, then which is maximum? Definitely 61 is a maximum. So maximum value will be assigned to a counter, new counter of the receiver. So this is the basics of Lamport's algorithm. In next session we will see how the Lamport's algorithm is actually implemented with the help of example. I have recorded a separate video for that. So thank you very much. If you have any query, you can leave the comment in comment box. I will definitely reply you. Thank you.